able to write it, if you are able to write the relation properly, then write the matrix. There only you will understand it. If the rank of that matrix is equal to number of unknown, two variables will be there, then you can write the linear combination, or else it is not. If you are not clear with the matrix, then you try to do it. Can you write it in any way? 1 comma 2 as a linear combination. The solution is there in the textbook that I have shared with you. Then next question is, T is a mapping from R2 to R2, where T of x comma y is x comma x plus y. Can anyone tell me what are the two conditions which can prove that the given operation is a linear transformation? You have to first check for,
Addition and
yes,
multiplication, ma'am.
vector addition, and the second one is linear scalar
A
multiplication.
scalar
Check
multiplication.
for those two properties under this relationship. If the LHS is equal to RHS, then T is a linear transformation. If any one fails, then it is not a linear transformation. Now, define Weibel distribution. Yesterday, I have explained you about the Weibel distribution, right? And when do you call it is a standard Weibel distribution? When alpha is equal to 1 and C is equal to 0. After substituting what is the answer, that also you need to mention here. Okay, next. In the unit 3, you have exponential and Weibel and MTTF. So your questions will divide accordingly. Now see here this question. Prove that V is equal to M 2 by 2, which is a 2 by 2 matrix where all elements of it are real numbers of R2. You have to prove it is a vector space. When they ask you to prove it is a vector space, you have to prove for all the 10 properties. Okay. So this is a lengthy question. The next one is, show that the three vectors are Li. How will you show the vectors are Li?
Check determinant, ma'am.
Check the determinant. If it is a 5 marks or 7 marks question, write the linear combination and show that the coefficients are 0. Therefore, the vectors are Li. If it is a more weightage question, if it is just 2 to 3 marks, then you can go for directly determinant. Okay. Then find the basis for the subspace. How do you find the basis for this any subspace V naught of R cube of all the solutions? This is the criteria. We are going to have the vector space as R cube. What is the standard basis for R cube? 1 0 0 0 1 0 0 0 1. Now you have to check this condition is satisfied by that, and then you have to create such basis. Okay. You want, I can share the key of this. I have the key for this question in detail solved. Then, or all these questions are there in the textbook. You please go through the textbook. You'll find many more problems of this sort. Justify the set whether x comma 2x with the standard operation R2 is a vector space or not. What is the problem with the vector space? Again, the same vector addition and scalar multiplication. I think one of the property fails. You all can check now and update me. Vector addition will work out, but what about the scalar multiplication? You have two vectors, no? Take any two vectors, 1 comma 4, 3 comma 6, and you do the operation. Is it a vector space or not? Is it a given set? Justify whether the set with the standard operation from R2 is a vector space or not. One of the property will fail, I think, therefore it will not, it is not a vector space. In the beginning only it will fail. Either the closure associative, somewhere around that it will fail. And then we have T be a linear operator from R2 to R2 only. Okay. Then T of x comma y is becoming 2y comma 3x minus y. You have to first find the images of these. What basis you are using? If they are not mentioning any basis, you will go with the standard basis 1001. But in this question, they have provided us the basis. Find the matrix representation of the T relative to the basis 1 comma 3 and 2 comma 5. It means take this value 1 comma 3 and substitute in place of 1 comma x comma y. You will get the respective output. Write that output as a linear combination of these two vectors. Coefficients or the coordinates of that linear combination you have to write as a vector, column vector, and that is called your matrix of the transformation. Okay, so you can try this. Determine the mean and variance of the exponential distribution. You can do each one separately, or you can write the one generating function, and you can derive the coefficient of 1 by theta, t power 1 by 1 factorial coefficient as mean, that is 1 by lambda or 1 by theta. Similarly, coefficient of t square by 2 factorial as variance, that is 1 by theta square. Okay. So these are all there in your notes. Just go through it, practice well. Now, next question is, if a map T is a mapping from R2 to R3, this is the relationship given to you, A plus B, A minus B, comma B. They are telling it is a linear transformation. So what will you do? You'll first write the matrix of the linear transformation. Find the rank of that matrix. Find out the row space, find out the column space. Based on that, you decide your R of T and nullity of T. How many elements of the domain are mapped to zero of the codomain. That information you will get from the matrix of the transformation. Thus, go and check for the rank nullity theorem. Okay. What is the dimension of the domain here? What is the dimension of the domain in this case? What is
One,
domain?
ma'am.
No, domain of this.
3, ma'am.
No, see, this is V2 of R means it is R2. And V3
2.
of R means, yeah, V3
Yeah,
of
2,
R means
ma'am.
3. So domain is 2. Therefore, your final dimension of the vector space of the domain will be 2 using the rank nullity theorem. Left hand side will be 2 and the right hand side you have to check from the rank of the null space and the rank of the column space. That is image set. Okay. It should be 3 minus 2 or something, or 1 plus 2 or 2 plus 0 something you'll get. You have to verify that. And then define the mean time to failure. And how do you find the mean time to failure? If they didn't mention with respect to which distribution, they asked you to just derive the formula, and that is there in your notes. Yesterday we have seen integration of R of t we got at the end. Remember? So integrating the reliability function in the given domain 0 to infinity is your mean time to failure. If they give you different R of t, you can go for different values or outputs depending on the reliability function. So overall, just based on the reliability function, we have one derivation. Yesterday we have seen, we have checked that. So you can do that derivation for this problem. So your question paper will be similar type only because we are covering almost all topics of all sections from each unit. So if you have any queries or you want to solve and get me the answers, you can make a trial of this. Will you try? Start solving. Just in first 10 minutes or 15 minutes, you will give me 3 answers. First 3 answers. Shall we start now? Okay. Others also, please give me a confirmation because talking is lot of done. You have the notes with you. You have the all references with you. Why don't you start solving and verify the doubts with me? You can share your screen or show me the notebook with the video. I can check out the mistakes if you have any. Everyone start solving, please. I'll try to check and find out what is the question paper of 2022 also. Can I stop sharing because you all have this question paper with you? Or even take a screenshot now for the moment. Once you are done, let me know. I'll stop sharing and go back and search for the 2022 MITS paper. Okay. Yeah.
Is the screen visible, ma'am?
Yes, it is visible.
Ma'am,
I think.
here
Tell me the question. Yes,
in the
proceed.
second question, actually, I didn't understand the question. Like how we need to
See,
prove here.
yeah, they are telling that prove that V1, V2 is linearly dependent when V1, V2 is already independent. When you have the vectors which are linearly independent, by introducing a new vector in it, it may be or it may not be Li. So what you will do, you will take the standard basis of R2. Okay. We'll do one thing. No, 1 minute. This question I'll just modify. You make it R2, please. In
R
R2. R2. Because if it is R3, 1 minute, 1 minute. Prove that V1, V2 is linearly dependent, where subset V1, V2 in R3 of a linearly independent and a vector V from R3. Okay, let me explain you first. R3 is a vector space. In that, you have certain vectors. It is already proved that two of the vectors are Li. Which are those two vectors? V1 and V2 are Li. And
yes, ma'am.
then we are introducing another vector V from the same vector space R3. When we are introducing this vector along with those two, a new set is formed. V, V1, V2. Now you have to check for the linearly independence nature of these three vectors. Okay.
Yes, ma'am.
Depending on V, it may be Li or it may not be Li. So they want us to prove that it is a LD. You can make it more better if it is R2. Make the R value as R2, then you can prove easily. V1, V2 is 1, 0, 0, 1. Make both the vector spaces as R2 instead of R3. Can you edit? Is it a PDF
Yes.
or a Word doc? It's a Word doc, no?
Word document.
Yeah, make it R2, then you will get the examples easily. Second
Okay.
problem, V1, V2 in R2. You click on that.
Yeah, okay.
Yeah.
Already.
Yeah. Then in such case, your V1, V2 will be 1, 0, 0, 1, and you are taking some V. V you can take as 2, 4 or 3, 7, some number you take, and you write the linear combination. Determinant of that will be LD, first case. You want to prove using the linear combination, write the linear combination K1, K2, K3 is equal to 0. One of the vectors will be non-zero. Maybe K3 will be non-zero or K2 will be non-zero, I don't know. One of them will definitely will be non-zero, proving that the given vectors are LD. We have done
Okay.
similar type of problem where E1, E2, E3 were the standard basis of R3. We want to introduce alpha and beta in it. So every time we were introducing one and deleting the other one. At the end, we got alpha, comma, beta, comma, V3. That concept you have to use here.
Okay, ma'am. Ma'am, in the third question, they are asking two distinct bases.
Yeah. What are the standard basis? This is R2, no? 1001. But they want you to find out something different from that. Write the linear combination, try with the numbers. You have these solutions in those textbook. Just check out under the basis section.
Okay,
How
ma'am.
can you write 3x minus y is equal to 0? What values of x and y you want to put so that it becomes 0? You have number of ways, no? Infinite number of ways. So take
Yes.
such two sets and check whether they are Li or not, and go for spanning verification of whether it spans V or not. If they are doing satisfying both conditions, those two sets can form a basis.
Can you give an example, ma'am, for third one?
Yeah. You have to find out the numbers. You have to find out such x and y values. 1, 3 or 7, 9, something, some numbers you have to take from R2. They have
Okay.
to for satisfy that condition. See, 3x minus y should become 0. Now think of x and y first. 1,
1 and
3.
3. Yes.
Then next is 2
Hmm.
and 6.
But they will be linearly dependent, right, ma'am?
Yeah. No, I'm telling you, it is generator. It is a
Okay.
generator, no? And then think of other also. Whatever you take, that will be a linear. That will be LD, no? Because there is a relationship between these, right?
Hmm.
You have to first check such numbers. 1, 3 is done. Think of some other number. 0, minus 3.
0,
0, 0, 0. 0, 0 only, right?
Yes, ma'am. Okay.
And no, will not take the trivial solution. Go for some non-trivial solution. 1 by 3 commas 1.
Yes.
Yeah. Now these two vectors you have found. Try to write, check whether they are Li or LD. Then go for the spanning. Write the linear combination. Are you getting the scalars non-zero? If it is happening, it is a basis. You got one distinct basis.
Hmm.
And then you have 1001, you can go for 1 1 and 1 minus 1. Try some different combinations.
Okay, ma'am. Ma'am, in the fourth question, you have asked three examples. In the sense,
Just name it. Just name it. Like polynomials, then the matrices of order 2 by 2. Just name them. No need to prove all the properties for all the three cases. Name the examples.
okay, ma'am. Okay. Ma'am, in the sixth one, is it R square or only R, ma'am, here?
R2 only because it's 2 by 2 matrix, no? Elements are from R2, but it is representing a matrix of order 2 by 2.
That means here each element in the
You can
matrix.
write R also. A, B, C, D all are real numbers. You can write only that also. Only R can also be satisfying. Because we are not taking ordered pairs, no? You can write R also.
Okay, ma'am.
M 2 by 2 of R means elements of the matrix which is of order 2 by 2 are all real numbers.
Okay, shall I make it R only, ma'am? Here?
Yes, you can.
Okay.
Okay, sure, is
Oh,
waiting. Let it.
that's it, ma'am.
Okay. Any more doubts, please? You can stop sharing if you. Any more doubts? A into echelon form. Is this step clear to you? We have to reduce this matrix A into echelon form. Come down. This is an echelon form. Can you see my cursor? Okay. Now, column space will have how many vertical columns do you have in this? 1, 2, 3. There are 3 vertical columns. I'll show you one more example where there are 5 vertical columns, but they are combinations of any one. So you will take the unique one, which is the Li in nature. Here, all the 3 are different, so we are taking all the 3. They are independent vectors, so I am taking 3. 3 elements are there in column space. Now go to the rows is above from there. I want to show you an example where 5 are there. See this example. Let's just scroll up. Given, find the basis for the column space of the matrix. So what is the matrix here? Minus 3, 6, minus 1, minus 1, minus 7. So we have got 3 rows and 5 columns. Okay, we will use the row operations to bring into echelon form. So what is this? This is the echelon form. You got it? Now you tell me which are the independent columns in it. Total count of the columns is 5. Yes or no? Give me a thumbs up. 100 minus 200 210 320 minus 1 minus 20. There are total count of the number of columns is 5. Yes? Give me a thumbs up. Okay. Now, out of this, you pay attention and understand 100 is a unique one. But if I write that has a multiple of minus 2 times of 100, I am getting the second one. So it means they are linearly dependent. Let us go to the next one. 210, 320. Again, these all the three are linearly dependent. With use of one vector, I can generate the other two also, no? So in total, out of the 5, only 2 are linearly independent. All the other 3 are depending on those 2. Therefore, our row space is first 2 rows is your row space, and the column space will be only the Li vectors. Let me come down. See here. Can you see the screen properly? I told you just now. 100 minus 200. Second vector can be, I'll call them as x1, x2, x3, x4, x5. I'm considering the columns, okay? x2 can be written as minus 2 times of x1. Am I right? Give me a thumbs up. So we have to ignore the LD vector. Can 1 comma 0 can be written as linear combination of any of the others? No. Okay. So this becomes my Li vector. Therefore, one of the vector in the column space is 1 comma 0, 1 0 0. Now go to the second part of the problem. There are three vectors x3, x4, x5. All the three can be generated using any one of them. Either you take 210 or you take 320 or you take minus 120. Any one you take and you will get rest of the two. So using any one of them, you can create a column space and the number of elements in that will be 2. First vector is 100. Second vector can be 210 or you don't want to take 210, you can take 320 or you can take minus 120. Anything. You can choose any two vectors which are Li in nature. Thus, you can create your column space. Is this clear now, Rohit?
Yes, ma'am, it's clear.
Ma'am, can you please share this PDF, ma'am?
It is with you. I have shared already. Should I share again? Check out your documents.
No, ma'am. This handwritten notes we
No,
didn't
no,
got, ma'am.
it
Actually.
is there inside this. See here. 1 minute. There, see. It is below that. Go and check, please. Same,
Okay,
same.
in first.
In the first unit only.
Okay, ma'am.
Yeah, it is there inside that. I'm going up, see. I have merged the documents actually. See, the same thing I taught you, I have given you.
Yes, ma'am, but last pages aren't included in our PDF, ma'am.
Okay, wait, I'll share again then, don't worry. Now only I'll share. Okay, give me a moment. I will stop sharing first. Give me a moment. I have to go to the WhatsApp.